Welcome CSC103 to a very quick overview of binary because I think the PowerPoint I have makes things even a little too complicated than it needs to be. So I'm going to try to make it easy. So I'll see if this works. If you don't like it, you could just watch the other PowerPoint. This is our base 10 system. You know how our numbers work. Basically, if we have a number 1, it looks like that. We have 1 in the ones place. And it goes all the way up to 9. And we have basically these 10 digits, 0 through 9. So we have 10 digits. That's where we get base 10. So we have 9 digits. Once it goes over 9, once we have more than 9 ones, we can't put anything more in the ones place. So we have to put a 0 there in the ones place, and we put a 1 in the tens place. Now this is our basic number system. So we have the number 10. That's what the number 10 looks like. Tens place, ones place. And then after we get up to 19, once there's one more, then it becomes 20. And there's a 2 up here. And there's a 0 up here, and then we have the number 20. You understand how that works. So there's the number 20, and then finally, if you get like 99, let's say we have 9 tens, we're up to 90, and then we have 9 ones. I'll move this down here, and I'll just copy this. So we have 9 tens and 9 ones. The number 99, when it goes over 99, then we bring a 1 into the hundreds place, and these become zeros. Go back and we put zeros up here and we have the number 100. You understand how that works. That's the way our number system works. We count the ones place, tens place, hundreds place, thousands place, 10,000s place, 100,000s place, million, and so on. So we know how to keep counting up. If we get to 1,000, it would look like this with all zeros. And then if it got to 9999, all nines, we'd have to go to the next place, the 10,000 place. So that's the way it works. And again, we only use 10 digits. 0 through 9 are digits that we can use. So we can't go over. Once they go over, it bumps over to the next one. So that's how binary is going to work. So let's take a look at binary and see if we can make that simple. Now here's binary. I have basically 4-bit and 8-bit. That means just like we had up to 1,000, here we're going up to 4-bit. Here we're going up to 8-bit. So it's a little easier to go up to 8-bit. But instead of 0 through 9, as far as our digits, we only have 0 through 1. That's all we can use. So once you get up to 1 and it goes over 1, you have to keep moving to the next one. So when there's the number 1 in binary is going to look like that. There it is. And sometimes you'll see the zeros preceding it. Sometimes you'll see 4 zeros, 0, 0, 0, 1. They might show it in 4-bit. So you might see something like this. I'll just put these up here for now. And again, they're not lined up really well. So hopefully that's okay. But you might see the number 1 shown like that. Now, when you have the number 2, then that would be only one number 2. So this would have to go down, and you'd only have one number 2. Now, you'd put a 0 over here because you have 0 ones. And by the way, whenever there's a 0 here on the ones place, it's always going to be an even number. And whenever there's a 1 here, it's always going to be an odd number. So right now, this is the number 2. And the next even number is 4. There's number 4. Now we skipped 3. What does 3 look like? Well, 3 would be 1, 2, and 1, 1. That would be the number 3. So 11 would actually be the number 3. So 1, 2, and 1, 1. We just keep adding up. So just for example, let me show you this. I'll bring these zeros down here. If we just look at 4-bit, we just go up to the 4 places here. And let's say we had this. 4-bit, the highest number it could be is 15 because we have 8 plus 4, which is 12, plus 2, which is 14, plus 1 is 15. So the highest number could only be 15 of 4-bit. We could count from there. So we do an exercise where we count up to 0 through 15. So all these combinations here through here, when we do that little exercise where we count up to 16, it's just using 4-bit. Now, once you start getting up higher, like for example, here's my age. I'm 54. Now, am I 64? No. So I'm not 64, so I can't put anything there. But I can put something here. There's 32. Now, what if I add 16 to it? 32 and 16, that's 48. So I still have more to go since I'm 54. So I'm 48. If you throw 8 onto 48, what's that? 8 plus 48. That's 56. That's too much. I have to put a 0 here, because that goes up too high. So that's 48 and 48. What if we add 4 to 48? 48 and 4, that's 52. Okay, now we have 52. I still have to get to 54, so we'd put a 1 here. That would make it 54. So now we have 48 and 0 and 4. 48 and 4 is 52, and 2 is 54. So that's 54. This would be my age in binary. That's my age in binary, 132. And then you could put zeros up here just to finish off the 8-bit. Sometimes they won't just put numbers. They'll either be four digits, or they'll show the full 8 digits of 8-bit. And this number, if these were all ones, now I have all the ones here, so I'll throw them all up here. If I had them all up here. Now this is a big number, and we won't work with the big numbers, but you'll see these a lot in technology. You'll see these numbers adding up for IP addresses and things like that. All kinds of stuff you'll see. Also colors will go up to there. 255. This is 255. If you add this up, 128 and 64 and 32, and you can use your calculator. I'm not going to do it in my head, but it'll come up to 255. And it'll be the number 0 through 255. 255 will be the highest. How do I know it's not 256? There's a 1 here, so it's got to be odd. So this is 255. So that's 8-bit. And 8-bit means there's 256 options, because we also have 0. So these could be all zeros as well. Now, let's just talk about another age. You guys are younger, and let's see. My son is 22. So I have a son who's 22. And is he 32? No. Can 16 go into 22? Yes. If you add 8 to that, does that go to 22? No, it goes over. It makes it 24. So we'll go here. That makes it 16, and then we'll add 4 to it. That's 20. And then we'll add 2 to that. That's 22. And then we have to put a 0 up here. So my son's age is 22. This would be his number in binary. There would be 116, 0, 8, 1, 4, which adds up to 20. And then 22, and then 0. Remember, even number always is 0, just like my age was an even number like that. And my daughter is 17, so she would have 116, or actually, she just turned 18. I'm sorry, she just turned 18, so this summer. So she just turned 18, so she would have 16 and 2, and everything else would be zeros. And that would be 18. That would be my youngest daughter's age. 16 and 2 is 18. And my middle daughter's age, she's 21. She just turned 21 this summer. She's all excited about that. So again, she couldn't be 32. She could be 16. She can't be 24, but she could be 20. So we could put a 1 here, and there's 20. And then if we need a 1, we got to move the 1 over here and move the 0 there. So that's 21. And again, it's going over 4-bit, because remember, if we're going over 15, we're going over 4-bit. So 15 is the limit for 4-bit. So if you're talking about people's ages 15 and under, they could use 4-bit. But then you have to go into the 8-bit range. And again, 8-bit is usually shown like this, even if you're not using the digits before them. It usually is in groups of octets, they call them, groups of 8, or they're in groups of 4, showing 4-bit. So that's kind of a little thing of binary. Hopefully that helps a little bit. Sometimes my PowerPoint overdoes things a little bit, so hopefully this helps out a little bit. Remember, this is, you just add them up. That's all it does, is it adds them up. So if my mom is 83, we'll do one more. My mom is 83. Is she 128? No, but she's 64. What if you add 64 and 32? That would be 96. She's not 96, so I'd have to put a 0 there. So how about 64 and 16? That's 70, that's 80. So yeah, she's 80, and then 3. Then there would be 3 at the end. So there would be the 1 and 1 at the end, which is 3. So 64 and 16, which I believe is 80. So there's 80, and then we add 3. So that's my mom's age there, of 83, going into big numbers. I don't know anybody who's going to get up using the 128's place. There may be somebody somewhere, but that could be talking about the age of a building or the age of a school or something like that. So anyway, that's binary. Hopefully that helps a little bit, or it adds a little bit to the earlier PowerPoint that I do on that. So let me know if that helps, if it helps at all, if it's any simpler than all those other things I did on the original PowerPoint.